So we're going to talk about the Carolina chickadee. This is a Carolina chickadee with the caterpillar in its beak. And the purpose of this little talk with some pictures is to illustrate how many different caterpillars it takes for even one nest of a very small bird to be able to have young. So a few facts about the Carolina chickadee. They're about 1/3 of an ounce. If you had 4 pennies in your hand, that would be about as much as a chickadee weighs. It's a very small bird. They forage within about 100-meter radius of their nest. They go from 6 in the morning until 9 at night looking for caterpillars. Both the mother and father bring back caterpillars. They feed their young for about 15 days during the spring. But how many caterpillars per day and per that 15-day period do you think it would be required for a chickadee to be able to feed its young? So here's a chickadee with 1 caterpillar in its beak. There's a chickadee with 2 caterpillars in its beak. Sometimes they bring back more than one to the nest at a time. There's a picture of a chickadee with 4 caterpillars in its beak. So they're very efficient. They come back to the nest about every 3 minutes, and they bring back approximately 30 caterpillars every 30 minutes because sometimes they're bringing back multiple caterpillars to their nest. So the answer to the question, it takes between 6,200 and 9,100 caterpillars to raise even one nest of chickadees. And you don't just want, if you have a wildlife refuge or a backyard habitat, you don't just want one nest of chickadees. You want breeding populations of chickadees. Hello?
Hey, Dad.
So you don't want just one nest of chickadees. You want multiple nests of chickadees because breeding populations are better for a population than just to have one nest. And you don't just want chickadees. You want as many different songbirds as you can because songbirds are declining and we need to help them out all we can. So take the 6,000 to 9,000 number, take that and multiply it by the number of breeding pairs of chickadees that you want, and then or the breeding pairs of each species, and multiply that by the number of species you want, and you're easily talking about hundreds of thousands of caterpillars are needed to feed even one nest of baby birds. So this shows the urgency and the importance and the urgency of having trees that produce caterpillars. So let's go to the next slide and see what it says. 230 species of North American birds were at risk of extinction as of the State of the Birds report in 2014. So, and then get to 2016, 430, almost half of North American birds are at risk of extinction. So there are 914 species of North American birds, and almost half of them are at risk. They're imperiled. It's different from being listed as endangered under the federal. A lot of those birds are not listed as endangered under federal law, but scientists are saying that they're imperiled, which is still very significant. And they're imperiled because there's been local extinction in so many different places, but local extinction is a different topic, so for another day. So this slide shows the let's look at the number of caterpillars on white oak versus Bradford pear versus burning bush versus black cherry. So start with the oak. The scientist who did this study is Doug Tallamy, and this is his front yard. And there may be more than 410 caterpillars on this tree, but he was just observing with the naked eye from just standing on the ground, no ladders, no nothing. And he counted the number of caterpillars. It took him about 3 hours to count the caterpillars on this tree. Counted 410 of 19 different species, and these are the ones: banded tussock moth, nason slug, pear slugs, bagworms, leaf tip rollers, and on down the list. So that's the number of caterpillars that were found on an oak tree. But go up on the same day at the same time, Bradford pear, only one caterpillar could be counted on a Bradford pear tree. So there's a big difference between 410 caterpillars and just one caterpillar. So clearly an oak is a much more productive tree in terms of the number of caterpillars that it can produce for breeding birds. And a similar comparison, is this the same? Similar comparison, same day on July 25th, 2014. Doug counted the number of caterpillars on this black cherry tree, and there were 239 of 14 different species. There were pear slugs, saddleback caterpillar, leaf tear caterpillar, tent caterpillar eggs, tenthreaded sawfly, Buccolectrix palmifoliella, leaf folder, tufted bird dropping moth, ugly nest caterpillar, leaf miners, large pyralid, Aclaris variegina, bagworm, and leaf rollers, but 239 caterpillars of 14 different species, and as compared with a burning bush which only had 4 caterpillars of one species on the burning bush. So that shows you that different bushes and trees are very different in terms of their ability to produce the caterpillars that our birds need to live on. So the moral of the story is plant oak, not Bradford pear, and plant a black cherry, not burning bush, because that's going to be better for the birds. Not to mention, not all caterpillars become bird food. Some of them grow up to be adult butterflies and moths, which are pollinators. And we know we need pollinators, so let's grow the trees and the bushes and the plants that are good for the pollinators. And that means the top 100 list. So this slide says sustainable landscaping versus unsustainable landscaping. What's the difference? Well, this is unsustainable because it's overrun with invasive species. Exactly what species are represented here, I don't know, but I do know that when you look at the woods and when you see trees up here and when you see dense green bushes down here, that's not the way a native Kentucky forest is supposed to be, and it's not the way a native an eastern Kentucky is part of a region, biological region known as eastern hardwood forests, and this is not the way eastern hardwood forests are supposed to be. Our native bushes are not dense and green like this. Plus, not only do you see bushes, but you see a lot of vines. These trees here are covered with vines, and vines are climbing up the trees. There's vines over here, and we have native vines, but such as winter creeper and grape, but our native vines are not hard on our native trees because they co-evolved together. You don't bite the hand that feeds you, and if you're a vine that wants to be able to climb trees, then you don't kill the trees that you climb on. Non-native vines such as porcelain berry and Asiatic bittersweet and English ivy and winter creeper, these are non-native vines that kill trees because they didn't co-evolve with them. They co-evolved with entirely different trees, and so this is unsustainable right here. That you look in a woods like that, it's very unhealthy woods, and it's similar. Most of our woods and our hedgerows and our fence rows that have trees are similarly infected and troubled with all these invasive species. So this is also unsustainable. These are ginkgo trees. People like ginkgo trees. They're pretty trees, but they don't provide anything for our wildlife. This scenario here is unsustainable. Ginkgo trees are nice, but they're not native and they're not good for our ecosystems. The leaves of a ginkgo tree do not provide any food for our native insects. The leaves of our ginkgo trees do not provide any food for our native caterpillars or our other leaf-eating insects, because our leaf-eating insects can only eat the leaves in the top 100, and not just the top 100, but it has to be native in order for our native leaf-eating insects, such as caterpillars, to be able to eat them. And that's the end of that slideshow.